Hello, this is part 3 of the absolute value inequalities examples. And in part 1, I briefly described what happens with greater than or equal to 6. In this example, I am going to work with greater than 6 just to show you what happens when there's not an equal to with the symbol. Okay, it follows the same general pattern, just there's one extra step without having the equal to. Now, let's try the absolute value of the quantity 5x minus 4 is greater than 6. So this means the distance between 5x minus 4 and 0 is really greater than 6. Let me zoom out a little bit. 6. Okay. So by seeing greater than 6, that's where we'll write that right there. So in part 1, I demonstrated what happens with greater or equal to, and I had that idea of the river, and you were standing in the middle of the river, and if you want to get to either side, you have to jump greater than 6 feet, right? And in that example, I put greater than or equal to 6 feet. But now here, so now I need to jump like 6.5 feet, or 6.1 feet, or 7 feet to make it to the bank, right? And you could jump in either direction, right? You don't always have to jump to the right. You can jump to the left. Okay, so by thinking of this, really if we mark the origin here, well then we can mark 6 and negative 6 out here. Now because of the greater than, that's not equal to, so I am going to leave this open. That's that extra step I mentioned a little bit ago. I'm going to leave it as an open circle. And what we saw is you need to get like towards 7 or 8 or 9 or 10 feet away, right? I'm just thinking of feet because it helps me make sense of these types of problems. And then if you jump to the left, well, you could have any of this shaded. So then if you think back to part 1 and how I described it, you could have this left-hand piece, or you have this right-hand piece, right? You have this or that, right? So that's where our or statement comes into play. Now, in this example, we are working with 5x minus 4 with absolute value. So I could think of 5x minus 4 has to be greater than 6, right? If I think of the right-hand side, 5x minus 4 needs to be greater than 6 if you think of over on the right. Now let's look at the left. 5x minus 4, and let's compare this to negative 6. Well, by introducing the negative, we know that we really flip the inequality. Another way to think about it is we're pointing to the left, so this would be 5x minus 4 less than 6, right? With the less than symbol, I think of it as an arrow, and it's pointing to the left where the shading is, and that helps me. Same thing with greater than. Greater than over here, think of it as like an arrow. It's shaded to the right, so I know that's how I could use that symbol. Okay, so then we have 5x minus 4 is less than negative 6, or 5x minus 4 is greater than 6. We just need to solve these. So I will rewrite this to give myself a little bit more room. Looking at this left one, I could add 4 to both sides. What I do is imagine that this is like an equals, right? I treat it like an equal to, but really I'm just keeping that symbol following through this whole time. So then when I add 4 to the right hand side, I'll be left with 5x on the left hand side, but on the right hand side I will have negative 2. And then in order to get the x with just a coefficient of 1, I will divide by 5 to get x less than, and because I divided both sides by a positive 5, I don't have to worry about any inequality rules. I will just have negative 2/5 on the right hand side. So now I have x less than negative 2/5, or I have to solve this other one. So I will do the same process. Add 4 to both sides. You get 5x greater than. Now 6 plus 4 actually gives you 10. And then, well, we can see here we need to get just x with a leading coefficient of 1, right? So x now is greater than 10 divided by 5 is really just 2. So then we have this, or x is greater than 2. So let's put that together as a number line. So let's mark 0. Negative 2/5 would be about there. Let me zoom in a little bit and fix that 5. I'm going to have that open. My 5 is still a little weird. I'm going to have that open because it's just marked with x is less than negative 2/5, or x is greater than positive 2. So positive 2, let's just mark over here. I'll have open. I'm going to shade greater than 2, and I'm going to shade less than negative 2/5. And we know that it's both open there. Now, thinking of this all together in interval notation, we could put negative infinity, comma, negative 2/5. I'm having trouble with 5s. Parentheses now, because there's no equal to. Union represented the or idea, right? And then I pick back up at positive 2, put parentheses, and go to infinity. So this would be my final solution in interval notation. And you could see that that matches up with the idea of the drawing here, and it matches up with the idea of you're stranded in the middle of a river and you need to jump either right or left greater than, say, 6 feet. Or you could even think of it as 6 meters or something like that. That's just the idea of thinking. Okay, so keep in mind, notice the difference between when you have greater than or equal to compared to in part 2. In the part 2 video, we had the less than or equal to 6. And in part 2, you could see the shading was in the in-between here. You could even see our final solution when we put it together, you shaded in between. But in part 3 here, we shaded in the outer regions because of the greater than. So just compare those two ideas and put it together. Now, in the part 2 video with the less than or equal to, we saw that we could write it as a compound inequality. Now, let's try to do that in this example. So let's rewrite our example, 5x minus 4 absolute value greater than 6. Okay. Now, if I tried to just rewrite it as so, if I put greater than 6 and then I put negative 6 here, and I put that greater than symbol again, right? If I mimic what we did in part 2, I'm going to show you that this actually will not work. Okay, so let's, I guess, work on this. Let's try to think about this. Well, you could add 4 to both sides, right? Add 4 to both sides, then you have negative 2 greater than 5x greater than 10. And then I divide by 5, divide by 5 everywhere. Negative 2/5 greater than x greater than 2. Okay, well, let's just think about this. Is negative 2/5 greater than a 2? Is negative 2/5 greater than 2? Does that make sense? Right? Let's mark negative 2/5. Is it greater than 2? Well, definitely not, right? That doesn't make sense at all. So you are not able to do this in this method. You can only do that as we did in the part 2 video with this example, like with the balance beam. You can do it there because if you look right here, 2/7 is less than or equal to 2. That is a true statement. Here, we wrote a false statement. This is a false statement all the way through. So we have to be very, very careful. That cannot work. Bad news all around. Do not do that. You do have to split it into the or statement. Splitting into the or statement is crucial. Okay, thank you for watching my video. I will do more examples in part 4.